In today's video, we're going to look at surds and, let's say, simplifying surds. This is something that's new in the syllabus. This year is obviously 2025, but it's not obvious. But anyway, I'm not really sure when you're watching this in the future or whatever, but it was added for the extended students to be able to understand how surds work and how to simplify surds. Now, just some basic information about surds and how we can work with them. A surd is just by definition when we have a non-square number under the square root, and then it will give us an irrational number, or it is an irrational number because it just repeats forever. So something like the square root of 3 or the square root of 2, these are surds, but the square root of 4 is not a surd because 4 is a square number, and that's just 2. There are certain kind of rules when it comes to these, let's say square root signs or radicals that you might call them. So if I had, let's say I had the square root of 100, that would be the same. 100 I can rewrite as 10 times 10, right? So that would be 10 times 10. And this is the same as this. Okay, so with multiplication and division, we can split these up. It's definitely not the same as this. I can't do this and say, okay, well, 100 is 90 plus 10, and then say this is, I'm going to make a non-equal sign just to prove it, or just to show this is not the case. Okay, so we have to, in order to simplify these surds, just to quickly do if you were to type this in your scientific calculator and you press the SD or the equal sign, it will give you this. And you're like, but why are these two things the same? So just like a half is equal to 2 over 4, these are equivalent fractions, but this one is the simplified version. These two are equivalent, but this one is the simplified version. This is also referred to as an exact value because if I were to work this out, I don't have my calculator with me right now, but if you had to put this in the calculator, you'll get a number that repeats, and it'll repeat as long as the screen is for your calculator. So whatever you write down is not going to be the exact value. Let me just do the square root of 2. I found a calculator here. Okay, square root of 2. Sorry, how does this one work? 2 square root. So it kind of shows me the square root of 2 is 1.41422135. But it stops because, I mean, my calculator can go on forever. So this is not an exact value. It's just a representation. I mean, I could probably, let's say I can rewrite this as 1.41 if I, I forgot the word now. Oh, can you believe it? I have stage fright. I don't know, can't remember the word. What do we write in the comments? Because I totally forgot what this word is. I can't believe it. Too much stress. That's going to bother me now. I'll remember it now. But anyway, so we can rewrite as this, but this and this is not exactly the same. So this is an exact value. Okay, round. Can you believe I forgot the word rounding? Anyway, so this is a form of rounding, but this is the exact value. So in your exam, they're going to sometimes tell you, give your answer in the simplified surd form or as an exact value. And in that case, you're going to have to give the square root number and not the actual decimal value. Okay, so let's take a look at how we get from here to here. Please don't write rounding in the comments now. Can't believe I forgot that. Anyway, so with that little rule, whenever I want to rewrite or simplify these types of surds or kind of big radicals, I'm gonna have to find factors that are square numbers, and I'll write some of the ones we usually use are 4, 9, 16, and 25. So these are the most familiar ones. 36 is there, and 49, and you know the others, and 1, but 1 we won't use. But we're going to look for a number, and we're going to try and find the biggest factor that's a square number of 80. Let's say I didn't know 16 was 1. Let's say I thought 4 was 1. So let's kind of just do it that way. So I would rewrite, and you don't have to do this extremely long method, but it'll probably help you. You'll probably end up doing the longer method because you will not get something like this in a calculator paper. This will be in a non-calculator exam. Okay, so 80, I'm going to rewrite this as, I know 4 can go in there, so I'm going to write 4 times 20, because that is the same as 80. I'm going to split that up into 4 times 20, and I know what the square root of 4 is. That's 2. So I'm going to write 2 times the square root of 20. So this is 2 times the square root of 20. But I know 4 can also go into 20. So I can do kind of the same thing. Let's kind of split it up again. We say 4 times, this is going to be 4 times 5. And this is 2 times, remember only with multiplication you can split these like this. And again, this is 2. So it's 2 times 2 times 5. Running out of space here, 4 times the square root of 5, and you can see this is the same thing. Okay, if I knew that 16 was 1 from the start, I'd go this route, and this would be the best option for me, is trying to find the biggest square number that's a factor of 80, and I can write this as 16 times 5, and I can write this as 16 times 5. And the square root of 16 is 4 times the square root of 5. So now this is simplified. Okay, we'll do another example. Let's just whiteboard this off. I'm going to keep my square numbers there as a reference. Let's do 100. Let's do the square root. Oh no, 100. I shouldn't do 100. That's too easy. Let's do 200 and let's do 300. Let's do 300. See what that works out. Okay, so the square root of 300, if you had to write this in the most simplified surd form, let's say what number, like 100 is actually a square number. I didn't add that there. So this can be written as, the biggest square number I can think of is 3. Well, let's make it 100 times 3. That's going to be a bit easier. 100 times 3. Okay. That's the same thing. I can split this into 100 times the square root of 3. And then 10 times 10 is 100. And the square root of 3. If I maybe didn't know, oh, 100 is the biggest one, maybe I looked into the 25 and I said, it could have taken me a bit longer, but it should have still worked out. So maybe I would have said 25 times 12? No? 25 times 10, 14. No. Yeah? Yeah? Oh my goodness. What is this? 300 divided 12. Yeah, it was 12. I don't know why I'm doubting myself there. Anyway, so 25 times 12, and this can be written as 25 times 12, and then this would be 5, the square root of 12. And you might think you end here and these two are not the same. So this is not the most simplified form, because there's another square number that can go into 12, and that is going to be 4. So this is 4 times the square root of 3. I skipped a kind of step there, but that's fine. And then 5 times, this is a 2, and the square root of 3. And then 5 times 2 is 10 times the square root of 3. Okay, cool. Please forgive me for forgetting some stuff in this video, like the word rounding. Oh dear.